بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is Stat 101, Major 1, Term 231. Let us have a look and solve the exam together. First question, multiple choice. Answer the following by selecting the correct answer. Okay. The mean and mode of the distribution plotted in the histogram is. So if you look to the histogram, we have numbers here, number and set 1, 2, 3, 4, 5. So that's discrete distribution, random variable. And the number 3 has the highest time, okay, here time appearing. So 3 would be the mode, and it's also the mean because the distribution is symmetric and it's mound shaped. The distribution here is mound shaped and symmetric. So the correct answer would be A. The mean and the mode is equal to 3. Second question, when a survey uses the responses strongly disagree, disagree, neutral, agree, strongly agree, this is an example of nominal and ordinal data when we don't have numbers. Interval and ratio when we have numbers. Here strongly disagree, disagree. These are not numbers. So either nominal or ordinal. The difference between ordinal and nominal, if we can order, if there is an order. So strongly disagree is greater or less than disagree. Agree is less than strongly agree. So we can order these responses. So the correct answer is B. For quantitative data, you know there is quantitative and there is also qualitative. Qualitative, no numbers, quantitative numbers. The relative frequency for a class. So there are numbers, so we can find what we call relative frequency. What is the definition of the relative frequency? We divide the frequency by the number, each frequency by the total number in the set N, okay, or summation. You can say summation of all the frequencies, okay. This is also N if you like. So the total number. So what is the definition of the relative frequency? Is computed as class width divided by class midpoint divided by class frequency. Yeah, we divide the frequency by what? By class interval? No, by the total frequency. So D is the correct answer. The coefficient of variation of a distribution is 55. And its standard distribution is 22. Standard deviation, I think here, this is standard deviation, not distribution. And the coefficient of variation should be given in percentage. So this is 55%, okay? Because you know the definition of coefficient of variation, it is sigma, or the standard deviation, over the mean times 100%, okay? So we can use this formula to find the mean. He needs the mean. What is the mean? Well, the standard deviation is 22, so that's sigma 22. Mu is not known. And what is CV? Well, we have to divide by 100 and remove the percentage bar. So 55 divided by 100 is 0.55. If we solve this equation for mu, then mu would be 22 over 0.55. So you can interchange mu with 0.55. And the answer, if you use the calculator, would be 40. So 40 is the correct answer. So the idea here is you have to divide 55 by 100, and then when you use the calculator, the answer is 40. Okay, the next question is about this graph, the box plot. The interquartile range of the distribution plotted in this box plot is given by is what? Well, what is the definition of the interquartile range? IQR is Q3 minus Q1. And where is Q3 here in the box plot? It is this one. It is represented by this bar. So this is Q3. And Q1 is here. So this is Q1. So Q3 is 33 and 26, 28. So this is 27. Q1 is 27. 33 minus 27 is 6. So the answer is B. And the last question, which is VI. The range of the distribution plotted in above box and whisker plot. So he needs the range. Well, the definition of the range is the maximum minus the minimum. Where do you see the maximum here? Well, this point is from the data. So the maximum is 36. We put it like this. If it is outside these borders. Also 20 is the minimum because this point is a point of the data. So we subtract 36 minus 20 and that's 16. So the range is 16 and the correct answer is C. So these are the multiple choice questions. Now the table below displays the number of bicycles produced at a factory from this year to this year. Create a bar graph. Well, select your preferred scale. Bar graph is like this, a Y scale and an X-axis and Y-axis. We put the year here on the X-axis and we put number of bicycles here on the Y-axis, okay? Now the number of bicycles, the minimum is 600 and the maximum is 1,200. I can do like this. So this is 100 by 100. That's my 100, but my 100 is small. So this is 1,000 and this is 1,200. So these are the number of bicycles. You can make it a bit larger, larger than this. It's no problem. Well, the first, let us put the years. Years start. This is year 1998. Okay, and this is 1999. This is 2000, 2001, and 2002. For the first year, I will draw like this, a bar up to 100. So 6, 7, 8. This is 100. So this is the first bar. 1999, 600. So up to this point, I'll draw a bar like this. It is not a histogram, so keep them not connected, disconnected like this. 2000 up to 900, so up to this point. So up to here, this is 900. And 1,100 up to here. So I will take this year to this. And this is 1,200. So this would be a bar graph. There are 25 students in a class. 5 students were randomly selected. So this is a sample. Their heights were recorded. Compute the variance. if the average height is 142.4. Well, this is the average of the sample. If you add these 5 numbers and divide by 5, you will find it 142.4. There are 2 formulas to find the variance. One of them, you use the average, x minus x bar. But one of them, computational formula, computing formula, is easier. It's just summation x square minus summation x all square over n all over n minus 1 if it's a sample. We divide by n minus 1. So all what I need to find is summation x. And summation x means I add all of these numbers, 131 plus up to 152. And if you use the calculator to add these numbers, you will find that the answer is 712. And we need summation x square, which is 131 square plus 148 square up to 152 square. And if you use the calculator also, you can find that the answer is 101654. So you just replace here summation x squared by 101654 minus summation x, which is 712. You need to raise it to the power 2 and divide by n number of elements in the sample, which is 5, and then divided by 4. Put it in the calculator. Evaluate the numerator first. Write 101654 minus 712 square over 5, then press equal, then divide by 4, and you will find that the answer is 66.3. You can also check your answer by the calculator. If you go to stat mode, okay, you go to stat mode, and mode 3, it's a stat, and you press 1 variance, and you put all these 5 numbers, 131 equal 148, and so on. And then you press on and shift 1, number 1, a stat. There is a stat above number 1. So shift stat and press number 4, which is variance. And Sx, which is number 4, is the standard deviation of the sample. If it is a population, you use sigma x number 3. So I need number 4, Sx, write equal, and he will give you an answer. Well, this answer is the standard deviation, it's not the variance. So press x square to raise it to the power 2, and you will find that the variance, which is s square, is 66.3. Okay. A study is being conducted in which a variable of interest has 1,000 observations. Well, this is n, okay? The minimum value in the data is 300, okay? And the maximum is 2,000, okay, 900. Use this guideline to determine the minimum number of classes to use in developing grouped data frequency distribution. When we construct a frequency distribution, first point is to determine the number of classes. And this is a guideline. We can use it to determine the number of classes. Well, I have 2 to the power k, and k would be the number of classes, okay, greater than or equal to n, which is the number in the data, how many numbers, how many observations, 1,000. And now to find k, we can apply len to both sides. And then we know if you have len, you can bring this k outside. This is attribute or a property of the logarithmic function. And then we can divide by len 2, and you will find that k is greater than len 1,000 over len 2. If you use the calculator to find len 1,000 over len 2, you will find that the answer is 9 point something, 9.96, okay? So k should be greater than that, so you choose k to be 10. So the number of classes should be 10. notice that you have to choose a number, an integer. Point is not good here because this is a number of classes. So 10 classes, this would be the answer. Based on the answer to part A, determine the class width. Well, the definition of the class width, it is the maximum minus the minimum over the number of classes, which is k, which we found here. So the maximum is 2,900 and the minimum is 300, and the number of classes, as we found in part A, is 10. If you divide, subtract and divide, you will find that the answer is 260. We should round this number up. The width is not like this. It should be rounded up. You can round it up to 265, to 70, anything. So what did he say here? Round up to the nearest 100 points. Okay. If you round up this to the nearest 100 points, 200, what is next? 300. So this would be the class width in this case. Construct a relative frequency. How do we find the relative frequency? We said we need to find the total of the frequencies. So if you add these numbers, 2 plus 25 plus 26 plus 7, you will find that the total is 60. Now the relative frequency would be 2 over 60. You can change it to decimals, okay? And you can round to 2 decimal places to find that this is 0.03, okay? And 25 over 60 would be 0.45. And 42, sorry. You can make sure of your calculator, of these calculations. 26 over 60 is 0.43, 6 over 60 is 0.1, and 1 over 60 is 0.017 or 6, so we can write it 0.02. Make sure that if you add all of these numbers, you get 1 because the total of the relative frequency should be 1. And cumulative relative frequency. Well, how to find cumulative? Here you put the same number as the relative, and then you start adding the next one. So 0.42 plus 0.03 would be 0.45. And then you add, this is cumulative, you add 0.45 plus 0.43 would be 0.88, and you add 0.1, and you add 0.02. If you add 0.1, it's not 0.89. If you add 0.1, it would be 0.98. And if you add 0.02, it would be 1. Okay, so the last number always in the cumulative relative frequency should be 1. Now construct an ogive. And he told you, what does it mean? Plot classes against cumulative relative frequency. So these are the cumulative relative frequencies. You put it here, cumulative relative frequency. So I need to divide this. So okay, let me draw. This is the y-axis, and this is the x-axis. Here, let us say this is 0.1, 0.2, 0.3, 0.5, 6, 7, 8, 0.9, and this is 1. And for the classes, you do it like this. You start from 0, then add 3, okay, up to 15. So this is 0, and this is 3, 6, 9, 12, 15. You can, if you like, you can take 2 here because it's large. So I can use 3 here, 6 here, 9 here, 12 here, and 15 here. That's okay. So at 0, you start always from 0. At 3, you put here, 3, you put 0.03. So 0.03 is less than 0.1. It's somewhere here. Okay, so you connect these 2 points. And then 0.45 at 6. 0.45 is here. This is 0.45. So you connect this line. And then 0.88 at 9, you have 0.88, which is somewhere here. Okay, 0.88. So you connect these 2 points. And then 0.98 at 12 is here. And then at 15, there is 1. So you go like this. And this is the definition. This is the OGIF. Okay, this is what we mean by OGIF. An instructor recorded the number of absents by the students on BSU Educate during past 14 lectures. Okay, these are the number of absences. The sample, this is a sample. Compute the following and show your calculations. Mean, well, the mean of the sample is called X bar, and it is summation X over N. So you add all of these numbers. If you add all of them by the calculator, you will get 58. And the total number is 14. Divide 58 by 14, that's 4.14. So that's the mean. Well, to find the median, I need to arrange the data. So the smallest is 2. I have another 2, and then 3, 3, 3, 3, 3, 5 times. And then I have 4, another 4, and 5, and another 5, and 6, 7, 8. Let me calculate 3, 6, 9, 11, 14. So these are 14, so I didn't forget anything. Now the median is in the middle, okay? You can use the index. The index is you divide 14, the total number of observations, by 2, so 7. This is the position of the mean. So 1, 2, 3, 4, 5, 6, 7. It's not the 7th. If it is an integer, you have to find the mean would be, the position of the mean would be 7.5. Okay, so in the middle between 3 and 4. So the median would be 3 plus 4 over 2, or just 3.5. 50% of the data should be to the right, 2, 4, 6, 7. 50% should be to the left, 2, 4, 6, 7. So 7 data here, 7 data here. The median is in the center, at the center. The mode 3, because it's the most frequent number, upper quartile, or he may ask about percentile here. So the upper quartile, if you remember, is the 75th percentile. And to find the I of the 75th percentile, I multiply 0.75, okay, 75th, 0.75 times 14, or 75 over 100, okay? And if you use the calculator, the answer is 10.5. Well, if I is an integer, I add 0.5, so 7, I go to 7.5. But if it is not an integer, I round it up. So it will be rounded to 11. And the observation in the 11th position would be Q3. So here, 7, 8, 9, 10, 11. This is the observation number 11. So Q3 is in fact 5. And you can see that Q3 is really the median of the upper half of the data. So this is Q3, and I can say that this 3 is Q1, okay? So Q3 is 5, and if he asks about any percentile, 90 percentile, for example, I use 0.90 and multiply by 14. Comment on the skewness of the distribution given in this question. Well, I can see here that the data, a lot of data is here and 3 only up, but also the mean is 4.14. And what was the median? The median is 3.5. Good. So this is important, that the mean was greater than the median. And if the mean is greater than the median, this means that the data is skewed to the right, okay? You're to the right or just right, okay? Because if it's skewed to the right, then the mean comes closer to the skewness. Here you will find X bar. Here we will have the median, and the mode would be here. This was the last question. Thank you very much for watching the video. Have a nice time.